Yeah, hi, am I audible? Please confirm. I'm audible. Thanks for confirming. So this is a demo class on DevOps with AWS. So the course duration is 2+ months. Today we are going to cover what are the contents. We'll see what are the contents we are going to cover in our course, that is 2+ months, and we'll have some basic introduction about the DevOps, how we can use DevOps in SDLC, and we'll have some basic introduction about the cloud computing, why we need cloud computing. Okay. So that is today's agenda. In our 2+months of course, so we are going to cover different tools from the DevOps. Like we are going to start our course with Git, okay? And we will cover Jenkins, Docker, Kubernetes, then Ansible, Terraform. Okay. Then we will cover AWS Cloud. Okay, so these are the tools we are going to cover in our course. So as a DevOps engineer, we need Linux basics. That is the prerequisite if you want to become a DevOps engineer. The prerequisite is Linux basics. We need some Linux basics. By considering this, by considering non-IT people, so we are going to cover. We are going to start our course with Linux. Okay, so we'll start the course with Linux. So no need to learn the complete Linux. Only basics of Linux is sufficient. So we'll have around 5 to 7 classes on Linux. We'll cover the required basics from the Linux, and after that we'll start with the DevOps tools like Git, Jenkins. Okay. So here, so before learning these tools, it is necessary to know why we need these tools. Okay, so why we are using these tools, where we are using these tools. So to know that, we must have some basic idea on the SDLC. So if you are from IT background, you know, you are much familiar with the SDLC, that is a software development lifecycle. Software development lifecycle. So if you are from non-IT background, so what is this software? SDLC is every software organization is going to implement one of the SDLC model. We have different SDLC models. So every organization will implement one of the SDLC model to complete any project. Okay? To work on any project, they need one of the SDLC model. We have different types of SDLC models like waterfall model, agile methodology, like that. We have different types of SDLC models. Okay? And here, so in any SDLC model, whether it is a waterfall model or agile methodology, whatever it is, so we are going to have different phases. Okay, so every SDLC model will have different phases. So in these phases, in these SDLC phases, we are going to use these DevOps tools. We will use these DevOps tools in the different phases of the SDLC model. Okay, so what are the phases we'll have in SDLC model? Eh? So why we need this SDLC, software development lifecycle, to work on a project. If we want to work on a project, we need any one of the SDLC. Okay, so Now, what is a project? What is a project? Project is nothing but development of an application and maintenance of an application. Okay, so we are very much familiar with different applications in our day-to-day life. We are using different applications, right? Like e-commerce websites like Amazon.com. Okay, so Flipkart.com, and we have banking applications like ICICI Bank applications will be there, HDFC Bank, different applications we are using in our daily life. Okay, so these applications, how we are getting these applications? These applications got created, got developed, and maintained by some software organization. Okay, so behind every application, there will be one software organization who is going to develop, who is going to maintain that. So that is nothing but the project. What is a project? Project is development of an application and maintenance of an application. Okay, so that is the main work of any software organization. So project, let us consider we are going to plan for some ABC project. Okay, so our project website is abc.com. Okay. Now, the motto of our project is we have to develop this particular application, develop abc.com. So, so for this particular application, if we want to start our project, we must have plan. Plan means what are the features we need in our application. So features means, so if you consider any application which we are using in our daily life, so we'll have login feature. Okay, so we'll have login feature, and if we consider most websites, we'll have product related information pages. Okay, so under product related, again electronics related pages will be there, fashion related pages will be there. So these are nothing but the features in the product. Okay, so login is one feature. So electronic related products page is one feature. Fashion related product page is one feature. So like that, we'll have different features in every project. So if we want to start our application, if we want to start our project, we must have plan. What are the features we need? Okay. The first phase in any SDLC model is we have to plan our project. Okay, so under planning phase, architects will come into action. Architects will develop the complete plan for our project. So let us consider I have five features in my project. Okay, I have five features in my project. So for these five features, so once we got a plan from our architects and the five features, in the next phase we have to develop the code depending on the plan. What is the plan we got from our architects, right? So depending on that plan, we have to develop the code. The second phase, so development team will come into action. So they will develop the code. Code development is the second phase. Okay. So who is going to develop the code? We are not going to develop the code. As a DevOps engineer, we are not at all going to develop the code. So development team will be there. Development team will develop the code. Okay. So dev team will be there. So dev team will work on the code. So as we have five features, so our dev team will try to develop the code for all five features. Okay. And if we consider the agile methodology, so development team is going to work on sprint basis. Development team will work on sprint basis. So what is the sprint is? Sprint is nothing but 2 weeks or 10 working days roughly. Okay. So 10 working days. So it will slightly vary depending on the organization, depending on the requirement. This sprint will vary slightly. Okay. So let us consider our development team is working on sprint of 2 weeks. Okay, means at the end of every sprint, one new release will happen. Okay. Okay. So at the end of every sprint, one new release will happen. So let us consider at sprint one, we got version one. Version one got released from our team, and at the end of the sprint two, okay, at the end of sprint two, so version 2 code got released from our team. So like that, I will have different versions of the code from the development team. Okay. Now we have to maintain all these versions of the code. Okay. We have to maintain all these versions of the code. So to maintain all these versions of the code, we are going to use version control system. Okay. So we are going to use version control system. VCS. Okay, VCS is nothing but version control system. Okay, so version control system. So this version control system is used to maintain the different versions of the code from our developers. Okay, so we have different version control systems like it. It is a version control system. So that is the purpose why we are learning Git. Okay. So once we did with Linux basics, we are going to start with Git. Why we are starting with Git? So by using the Git, we are going to maintain the versions of the code from the development. Okay. So that is the work of DevOps team. Yeah. Okay. So we are not going to develop any code. Just we are going to maintain the code. We will maintain the code from our development team in the Git in the version control system. By using version control system, different versions of the code we are going to maintain by using Git. Okay, so that is the purpose why we are learning Git. So in the Git, we are going to learn from basics to advanced topics. Okay, so we'll learn how can we install Git, and so how can we create branches, how can we manage branches. Okay, so what is the staging area, what is the local repo, remote repo, all these things we'll learn in the Git. So in the Git, we'll start from the basics by considering the beginners. Okay, so we are going to start from the basics and we'll cover advanced topics like Git cherry pick, Git rebase. So all these things we'll see in our course. Okay, so that is about Git. That is the purpose why we are learning Git in our course. So in the SDLC process, as we are using Git in one of the phase, we are learning Git. That is the purpose of learning Git. Okay. So now, once we have code in our version control system, okay? So once we got the code in our version control system, we have to work onto the code. Okay, we have to work onto the code. Means we have to build the code. So the next phase in SDLC model is to build the code. Okay. So build means under build again we have different operations, different stages. Like I'm going to compile the code. We will validate the test cases. Okay, and we'll do the quality checks. Code quality checks we will do. Will package them. So these are the other stages we have in the build phase. Okay, so after development of the code, so once we have code, we are going to build our project. So build phase will include the different stages like compilation of the code, validating the test cases, performing the quality checks, and doing the packaging. So these are the different stages we have under build phase. So to maintain the code, we are using Git. Okay, so from our development team to maintain the different versions of the code, we are using Git. Similarly, to perform build operation, okay, to perform the build operation. So we are going to use CI/CD tool. Okay, so we will use CI/CD tool. So here CI/CD is nothing but continuous integration and continuous deployment. So we'll discuss about a CI/CD. What is a CI/CD? How it happened? Okay, in the comment section. So as of now, just remember, the CI/CD is nothing but continuous integration and continuous deployment. So to perform the build operation, we will use a CI/CD tools like Jenkins. Okay. So Jenkins is a CI/CD tool. By using this Jenkins, we are going to build our process. We are going to build our, okay. So that is the purpose why we are learning Jenkins. Once we completed Git, we'll move to Jenkins. In the Jenkins, what we are going to do is we are going to create different types of like pipe, that is projects. Okay, so we will create a different types of projects like a freestyle project. Okay, so freestyle project, and we'll create a pipeline project. We will see how can we create a CI/CD pipelines. Okay, and how can we implement Maven. Okay, Maven project. Or like that, we'll create different types of projects, the Jenkins. So here, so by using these projects, we are going to perform these operations: compilation, testing, quality checks, packaging. So these operations Jenkins cannot perform directly. Okay, so Jenkins is not going to perform any operation directly. What this Jenkins will do is Jenkins will take the help of third party tools. Okay, so Jenkins will take the help of third party tools like Maven. Okay, so Maven is a build automation tool. So it is a build automation tool. So by using Maven, we are going to compile the code, validate the test cases. We are going to package the code. Okay. So what this Jenkins will do here? So Jenkins just trigger the Maven. Maven is going to perform the required operation. So we will learn about the Maven also along with Jenkins. Okay. So when we are covering Jenkins along with Jenkins, we will learn about the Maven. Maven is a build automation tool, and we'll learn about the quality check tool like a SonarQube. We'll learn about the SonarQube also. Okay, so this will come under Jenkins only. These are the different again additional tools now. Okay, so now we are going to learn about the Maven to perform the build. Okay, to how can we compile, how can we test, how can we do the packaging. So these things we'll learn, and to do the quality checks. Okay, so we are going to integrate SonarQube. Okay, SonarQube with the Jenkins. So SonarQube is a to check the quality, code quality. To check the code quality, we will use SonarQube. Okay, so we'll integrate Jenkins with SonarQube, and Jenkins is going to trigger SonarQube. SonarQube will perform the quality checks. Okay, code quality checks will be performed with the Sonar. Okay, so all these operations will happen under build phase. So under build phase, we are going to use the tools like Jenkins, Maven, SonarQube. Okay, now once we are good with these stages with the compilation. Okay, so for our code, compilation is success. Let us consider, and so testing is success, and quality checks is success. And then we will do the packaging. Under packaging is we are going to get artifacts. So these artifacts required to deploy the code. Okay, so these artifacts required to deploy the code. Now, once we complete with build phase, next stage is deployment. Next stage is deployment. Okay, so deployment means we need artifacts to perform the deployment. If we have artifacts, we can deploy these artifacts. Once we deploy the artifacts, our project will come into life. Okay, so once our project is live, we can end users can access our application. Okay, once the project is live, end users can access the application. So these are the different phases we have in any SDLC model. Okay, in any SDLC model, so we'll have different phases like planning, development of the code, build, and deployment. Okay, so in the development of the code, we are using Git, which is a version control system. In the build phase, we are using Jenkins, which is a CI/CD tool, and along with Jenkins, we are going to use Maven and SonarQube to perform the compilation, testing, and quality checks. If everything is fine, we'll get artifacts from our pipeline, from our Jenkins CI/CD pipeline. We'll get artifacts. So these artifacts, if we deploy, our project will come into live. Okay, so these are the different phases we have under any SDLC model. Okay. Now, so once we got the artifacts, while going with the deployment, okay, so while going with the deployment, so we can follow two ways for the deployment. Okay, so what are the two ways is we can directly deploy artifacts. That is one case. So another way is instead of deploying artifacts directly, so we are going to deploy images. This is another case. Okay, so deploying artifacts directly is the traditional way of deploying. Okay, deploying the artifacts directly is a traditional way of deployment. Okay, so here we have some drawbacks if we are trying to deploy our artifacts directly. So we have some drawbacks. What are the drawbacks here? So this deployment depends on the environment configuration. So we will have different types of environments in any software organization. So we'll have different environments like we'll have dev environment, okay, and we'll have QA environment, okay, and we'll have UAT environment. Finally, we'll have prod environment. Okay, so these are the different environments will have any software organization. Okay, so in dev environment, development team will be there. Okay, so development team will be there. So development team will try to develop the code depending on the requirement. So we know that we have different features in our project, right? So depending on the feature, development team will try to develop the code, and so they will test the code in their environment only. In dev environment only, they will test the code whether the code is working as per the requirement. They will test it. Okay. Now, as the code is getting developed by the development team, so if there is any prerequisite for the code to run without any issues, okay, so then they will maintain the required environment configuration. So let us consider. So we need Java 11. Okay. So for our application to run successfully. So that Java 11 is the prerequisite. Let us consider. So development team will maintain the required Java 11 in their environment servers, and the code will become successfully deployed in their environment. Okay, so once the code is got successfully deployed, so they will got sign up from the dev lead. There will be dev lead. Okay, so there will be dev lead. So dev lead will provide the sign off for the code. So the team will get the sign off from the dev lead. And once we got the sign off, the same code, whatever the code we tested in dev environment, right? The same code will move to the next environment, that is the QA environment, that is testing environment. In the testing environment, so QA people will be there, testing people will be there. Okay, so testing people mm, are not going to bother about the environment configuration. What they will do is, whatever the code they got, right, the same code they are going to test, they are going to test. Okay, so let us consider in testing environment they are not maintaining the required Java 11, they have Java 8 only. Okay, so for our application, what is the prerequisite here? Java 11 is a prerequisite. So development team maintained Java 11 in their environment. So the code runs successfully, code deployed successfully. But in QA environment, Java 11 is not there. They are using Java 8 only. So definitely code will fail. So what is the reason for failure of the code here? There is no change in the code. What is the code we used in dev environment? Same code is getting tested in QA environment also. Only there is a change in the environment configuration. Dev environment has Java 11, QA environment has Java 8. Okay. So even though there is no change in the code, so due to the change in the environment, the code will fail. Code deployment will fail in the other environment. Okay, so the same code is getting successfully deployed in one environment, it is getting failed in other environment due to the environment configuration changes. So like that issues will get if we directly deploy the art. Okay, so now, once the code got failed, again PA team will send notifications to respective dev team. So code is not working as per the requirement. So some investigation will happen. So all these things will take some time to identify the actual issue. Okay. So finally, what will happen? Finally, what will happen? So we are not going to get the sign off within time for our application. We are not going to get the sign off within time, and production will be delayed. Okay, production will be delayed. So that is the problem here. Okay, so if the production got delayed, it will affect the business of the organization. So like that issues will have if we directly deploy the artifacts. Similarly, in production environment, so if we release any new version, if the new version is not working as per the requirement, then we have to immediately roll back to the previous stable versions. Okay, so rollbacks also difficult with the traditional way of deployment. If we deploy artifacts, so rollbacks also not that much of easy. Okay, so like that we have some problems with the deployment of the artifacts directly. So by considering this, so nowadays most of the organizations are moving towards the image deployment. They are going to use images for the deployments instead of artifacts. Okay, so this is the new way of deployment. So to perform this deployment, to deploy our images, we are going to use Docker, okay, and Kubernetes. We need Docker and Kubernetes deploy the images. So what this Docker will do is, so this Docker will create the image from the artifact. Okay, so what is an image? Image is nothing but the single package which is embedded with the application code. So this image will have the application code and binaries, libraries, and other dependencies, whatever we need for our application to run seamlessly. Okay, so everything is embedded in the image itself. So who is going to create this image? Docker is going to create this image. Okay, so that is the purpose why we are learning Docker. Once we done with the Jenkins, once we done with the Jenkins, Maven, SonarQube, so we are going to get the artifacts. So to convert these artifacts into images, we are going to learn Docker. Okay, so Docker is a containerization tool. Kubernetes is a container orchestration, container management tool. Okay, so by using the Docker we'll create images and then we'll create containers. So to maintain all the containers we'll use Kubernetes. So that is the reason why we are learning Docker and Kubernetes. So this Docker and Kubernetes is a containerization tool. Okay, so these are the containerization tools. So by using these containerization tools we are going to convert our artifacts into images. So once we got the image, so if we consider the same example, okay, so what will happen if we deploy images is, so the required prerequisite, the required Java 11 we are going to maintain in the image itself. Okay, the required Java 11 we will maintain in the image itself. No need to bother about the environment configuration. Okay, so in the environment if we have Java 8 or Java 11 or some other version of Java, no need to bother, because the required configuration will be embedded in the image itself. So if the image works in one environment, okay, if image works on one environment, the image works on one environment, so no need to bother about the other environment deployment. Okay, definitely it will work on all other environments. So that is the advantage we are going to have with the images. Okay, so it will work on all other environments. So no need to bother about this failure. So once our image is successfully deployed in one environment, so no need to bother about the environment configuration. Irrespective of the environment configuration, our deployment will become success in all the environments, and there is no way of delayed production. Okay, we will have in-time production. And if we use the images, so rollbacks are easy. We can do the rollbacks easily. So like that, we have many advantages with the image deployment. So that is the reason why we are running Docker and Kubernetes. By using this Docker and Kubernetes, so we will create the images and we'll deploy the images. So by considering all these advantages, nowadays most of the organizations are moving towards this containerization tools. They are trying to implement Docker and Kubernetes. Okay. So that is the purpose why we are learning Docker and Kubernetes. And after that, we learn about the Ansible. So what is this Ansible is? It is a configuration management tool. It is a configuration management tool. So what is this configuration management tool means? So let us consider. So I have 1,000 servers in my organization. I have 1,000 servers. So I want to do the patching. Okay. So I want to do the patching on all the 1,000 servers, on all servers. So patching means I have Java 8, I want to upgrade to Java 11. So like that, some patching work. Okay. So if I want to do like this patching works, I have to do these things manually, right? Okay. So if we are doing the patching work manually, so let us consider it is taking 30 minutes per server. It's taking 30 minutes per server. Okay. If we do manually. So if we do the manually to complete this patching work on all the servers, so 1000 servers we have, right? So we need 500 hours. Okay, 500 hours. We need 500 hours to complete the patching on all the 1000 servers. So if you see here, so spending 500 hours for a simple patching work. Okay, spending 500 manual hours for doing the simple batching work is not the feasible. So if we have 10,000 servers, you have to spend 5,000 hours. Okay, so this is not the feasible way. Okay, so to perform like that activities, to perform like this activity, we are going to use configuration management tools. Okay, so if we are using Ansible, so what will happen is for the same activity, okay, so if we are using Ansible, so there will be Ansible controller, there will be Ansible controller. So this Ansible controller, so it will connect with all thousand servers. Okay, it will connect with all thousand servers, and so it will run a simple script on all the servers at a time. Okay, to complete the patching. What is the patching work we have, right? So to do that, simply this controller will run the script on all the thousand servers parallelly. Okay, so how it will happen? Script execution will happen parallelly. If that is the case, so what this Ansible controller will do is it will do the patching in 30 minutes in all the thousand servers. No need to spend 500 hours. Okay, so it will complete patching in just 30 minutes in all the thousand servers. So like that repeated activities, if we want to perform, we are going to use configuration management tool. So similarly, so let us consider I have DB password of one of my database maintaining. I am maintaining this password in around 1000 servers. So if I want to change the password, simply I can run one script through the Ansible. Okay. So no need to change the password manually in all the 1000 servers. Okay. So what we can do simply we can create one script. We'll run the script. If we run the script, so this Ansible will replace the required password with the new password. So like that repeated operations. To perform like that repeated operations, we'll use the Ansible. Similarly, so on all my 1000 servers, I want to start my Apache. Okay, so I want to start my Apache application on every day 10 a.m. That is also repeated work, right? Simply we can use Ansible. Ansible will start the required application on all the 1000 servers at the specified time interval. So like that operations we can perform by using the Ansible. Okay, so we'll see how can we write the script, how can we do this repeated works by using the Ansible. Okay, so that is the purpose why we are learning Ansible. Ansible is a configuration management tool. Okay, so after that we are going to start AWS before Terraform. Okay, before Terraform, we'll start with cloud computing. Okay, so in the cloud computing, in the AWS, we are going to learn how can we create EC2 instances, how can we create a VPC. Okay, so how to work with elastic load balancers. Okay, so how to use the S3 buckets, okay, EBS volumes, and IAM. How can we use IAM? Okay, so how can we use CloudWatch? So like that, different services we are going to learn RDS. We learn about the RDS and simple notification service. Okay, so all these services we learn in the cloud computing. Okay. So what is this AWS? AWS is a cloud provider. Amazon Web Services is a cloud provider. So we will have two types of infrastructure, like on-premises infrastructure and cloud infrastructure. So if we are going with on-premises infrastructure, so maintenance of the infrastructure is additional headache to the organization. So nowadays, most of the software organizations are moving towards the cloud, okay, to get rid of this maintenance part. Okay, so if we are implementing cloud computing in our project, what will happen is, so the required services will be, we are going to hire, we are going to get on rental basis the required services like servers, databases, storage devices. So all these things will get from the cloud provider on rental basis. Okay, so if we are going with the cloud, so how much we use, for that only we have to pay. Okay, so we can utilize the resources efficiently. Okay, so we can utilize the resources efficiently with the cloud computing. Okay, so like that we have many advantages with the cloud computing compared to the on-premises infrastructure. So that is the purpose why we are learning AWS. AWS is one of the leading cloud provider to Amazon Web Services. In Amazon Web Services, we are going to cover the different services. We'll see all these services and we will try to create these services manually. Okay, we'll create all these services manually. And once we're done with cloud computing, we are going to start with Terraform. So what is this Terraform is? Terraform is a infrastructure as a code tool, IAC tool. Okay, infrastructure as a code tool. So what this Terraform will do is, so here we are going to write some Terraform scripts to get the required infrastructure from the cloud. So in the cloud computing, we are going to learn how can we create different services manually. All these services, EC2, VPC, ELP, S3, all these services. How can we create manual? Okay, that thing we'll see from the cloud computing. Now, in the Terraform, the same services will try to create by script, by using script. How can we create these services by using script? So that thing we see from the Terraform. Okay, here always we are going to write one Terraform script, and if we execute the script, the required cloud service is going to be created. So no need to create these services manually. No need to delete these services manually. So everything, okay. So no need to auto scale these services manually. So everything will happen through the script only. Just we have to run the Terraform script. Once we run the Terraform script, the required services will be created. So that is the purpose why we are learning Terraform. So this Terraform will work with any cloud, not only with Amazon Web Services. So if you know Terraform, you can work on any cloud like AWS, Azure, okay, GCP on any cloud. You can work with the Terraform. Okay. So that is the plan for our course. So that is the reason why we are learning all these tools. Okay. So Docker, Kubernetes is a containerization tool. Ansible is a configuration management tool. Terraform is a infrastructure as a code tool. Okay. AWS is a cloud provider. So these things we are going to learn from basics to advanced level in our course. Okay. Okay. This is the agenda for our course. So that's for today. If you have any doubts, you can ask now. Any doubts after now? Okay, we'll inform when the batch is going to start. Okay, so we'll inform you. Yeah, at the end of every class, I will provide a recording sessions. Okay, so I will provide recording sessions, and at the end of every tool. So we will have assignment topics. Okay, so will provide assignment topics at the end of every tool. So you have to submit the assignments within the time frame. So these assignments will help you to improve your knowledge. So these things will do. Okay, thank you. Thanks for joining the demo class. I'm going to stop here.